Hello, dear students. So, I'm Kritika Bhavsar, and I've done my bachelor's and master's in applied mathematics and computer science. And today I'm here with a new series to help you all because, as we know, the exams are right on our head and ICSE especially I'm targeting. So if you are an ICSE student, really worried about what is going to happen in your exams, then you're at a correct place. Today, I'm going to start a series of videos where if you know zero, I repeat, if you know zero knowledge about any concepts of mathematics, especially for ICSE board, this is the place where you need to be. You need to watch the entire session that I'm creating, and I assure you a 100% that you will be able to solve the questions in exam and not just solve them, but with accuracy and speed. So, with that, let's just get started. I'll share my screen. So as we know that we have our ICSE math paper on 2nd of March, as far as I remember. And before we begin anything, this is the distribution, as clearly we all know, right? So the algebra, let's see what chunk is taken by what. So we know that algebra is taken 30 marks. We know that geometry is 20 marks and each of the other sections go for 10-15 marks each, right? Now, today I'm going to start with algebra because as you can clearly see, it's 30 marks weightage out of the entire 80 marks paper, right? So let's begin with algebra. Today's session is going to be focused only on this. So if you have no doubts related to algebra, you can go and watch my other sessions where I have covered all the other topics. And soon we'll be covering specific related questions. Those are very helpful for examination. So this is a bootstrap camp for you all to prepare for the exam. Okay. Now, algebra, we have linear inequations, we have quadratic equations, and solving simple problems. Again, that is a part of quadratic equation. So, we are going to cover these two in just one go, in one class. Then we have ratio and proportion, which is a very interesting chapter if you really understand. And it is the most applied chapter in real life. Okay. Then we have remainder and factor theorems. We have matrices, AP and GP. Again, AP and GP we are going to cover in one particular session. Okay. So today's focus is going to be linear inequations in one variable. Let's begin with questions. Let's attack on questions. So now when I say on questions, I mean I'm going to solve these questions for you all, but at the same time, I want you to actually go through them before you watch the lecture so that you just have kind of a self analysis of how much you actually know about the topic that we're going to learn. And the level of questions, the difficulty is going to increase step by step. Okay, so again, this is for somebody who knows nothing of the new chapters. Now, okay, we need to identify if the following statement is true or not. So we have, what do we have? We have minus 5x is greater than 15. And that is actually implying the following that x can be greater than minus 3. And we need to tell if this is true or not. So let's kind of do it in the traditional method that we have learned in schools, which is this. If you have an equation like this, what do you start doing with it? You first divide the entire thing by minus 5, right? So when you divide it by minus 5, you have x greater than 15 over minus 5, which is x greater than equal to minus 3. And by that logic, this should be true. But is that really the case? Because most of the students do this approach and then they write the answer as true. But no, this is not true. And where is the problem exactly in this? So there is a quick note for all of you, which is whenever you divide or multiply an inequality by a negative number, you must flip the inequality sign. So the inequality sign actually flips, interchanges. So for instance, let's go back to our question. Our question was minus 5x is greater than equal to 15. Now, I have decided to multiply both sides by minus 5. Minus 5 is a negative number. So if you divide or multiply by a negative number, you need to flip the sign. And then you divide, you continue doing the same process as it is. So you have this as minus 3. Now, this is what logically tells you, and the real answer goes as true. This is what the logic tells you. Okay. But what if you don't remember the logic or you don't want to go through the tedious process of solving this? In that case, I have a short trick for you. Now, this short trick is not actually some gateway, but actually a logic. Okay. So, okay, what your question is saying? Your question is saying that x is actually greater than minus 3. I want you guys to think of a number which is actually greater than minus 3. So, what is the number? Greater than minus 3? It can be minus 1, right? So, as a number line, if you have 0, if you have minus 3 here, all these numbers are greater than minus 3, right? So, you can take any number. So, I chose minus 1. Now, if you choose minus 1, let's put this minus 1 here. So, what do you have? You have minus 5 into minus 1 should be greater than equal to 15. But is that really the case? Minus into minus is plus, so you have 5 greater than equal to 15. This itself tells you that it's false. The statement is not true. Okay? So this is a quick way to check. That is, go towards the implication, choose any number which satisfies this equation and put that number here, and then check if it is true or false. Okay, let's move towards a little bit more practice of such questions. So now we have this question. Okay, here we don't have x to imply our earlier method and we purely have to go through the tedious process, right? Okay, but what do we have? We have 7 greater than 5. And if 7 is greater than 5, they say that, okay, this actually implies that if you take it in denominator, it is going to flip the sign of inequality. Okay. Um, okay, let's exchange 7 by A and let's exchange 5 by B. So what do we have in that case? We have 1 over A is less than 1 over B. Okay, when A is greater than B. Is that true? What do you think? Let's try it for some other number or the number that is given right here in front of you. What is 1 over 7 if you divide it? 7 ones are 7. 7 zeros are point. Now you have here 10. Ones are 7. Right? Okay. And let's see what we get here. 5 is a 5. 5 zeros are. Then you have a decimal. You have 10. 5 twos are 10. Is 0.2 greater than 0.1? Yes, because the number line, right? Okay, so this is true for any A and B. This is something important result that we need to remember. In other way that we can remember this result is how the greater the denominator, the lesser the value of fraction. This is a very important result that you're going to need for all the type of questions where fractions are involved. Okay, let's move towards another result. So this session is entirely going to be result based. I want you guys to remember. So these questions are not randomly picked questions. They have been chose very sensibly, and those are everything that you will need for the examination for those 30 marks. Let's go towards another question. It says if A is greater than B, then if you add some quantity C in A and B, the equality still holds. What do I mean by this? Here it was greater than, and it still is greater than regardless of any value that you add, given that value is same. So on LHS and on RHS, you're adding the same value C. Is there any information given to us about the C or how it behaves? No. So C can either be positive or C can be negative. According to the earlier method I had given you, that take some numbers and check if the inequality holds. Let's try to do that. Let's first take a A and a B where this is true. So let's take this 5 is greater than 2, right? Okay. Now what do we have? C. Let's take a positive C in this case, and the positive C case will be, let's suppose, 3. It says that A plus C is something as compared to B plus C. Let's see what it is. Okay. So A plus C, 5 plus 3, and here you have 2 plus 3. So you quickly have here 8, you quickly have here 5. So you have the greater than sign. And this sign is still as it is. Right? Let's try for negative 3. Let's see what happens for negative 3. Again, you have A plus C and you have B plus C, and you don't know what they are going to behave like. Okay. So A plus C, 5 plus minus 3 and 2 plus minus 3. Okay. 5 minus 3 is 2 and 2 minus 3 is minus 1. And it is still greater than. So this sign is still intact. So this is true for all C, right? For all kind of C. Okay, let's move towards a similar type of question. Again, concept based question. If you guys know very well, good, you can move to the next question. You can forward the recording. If not, please pay attention to this question. So if A is less than B, then we have the following saying that the sign changes. Sign flips. Earlier it was less than, now it becomes greater than when you multiply it with some quantity which is same on both the sides. Is it true? Is it false? Let's check. Let's again take examples for A less than B. This is given to us. So let's pick an example. 2 is less than 6. And then we have a C which can either be negative or can be positive. It can either be negative or positive. For negative, let's take C as positive. Let's take 3 and minus 3 are general examples. Let's see. Now you have to multiply that C, right? So your equation, oh, I'm so sorry. So your equation is going to be AC less than BC, and we need to check if AC is actually less than BC. So we need to find out the relationship between them. AC, so 2 into 3. Now for positive C, we are checking this. Okay. So 2 into 3 is 6, and 6 into 3 is 18. What do you have? What do you have? 6 into 3 and 2 into 3. You have greater than. Okay. What happens for your negative C? Now your negative C is minus 3, and you have to find relationship between AC and BC as usual. So minus 3 into 2 is minus 6. And minus 3 into 6 is minus 18. What do you have? You have minus 6 greater than. Okay, so here's the trick that you have. The dilemma that when it was positive C, you have the sign intact. But when it is negative C, you have the sign flipped. That means this actually depends on C. So this statement is actually false because we don't know what C here is, right? We don't know what number they are multiplying on both the sides. The answer totally depends on that, and hence this is false. Let's move towards next question. Again, which is a very conceptually strong question, like a base for your understanding. If A is less than B and C is greater than 0. So now we have some value on C, which is C is always positive. Okay. And A is less than B is also given to us. So let's take our traditional example. 2 is less than 6. Now there is some number C which is positive and is subtracted from both the side. Let our C be 3. So let's subtract and see what sign we get. Okay. So 2 minus 3, and we have 6 minus 3. 6 minus 3 is 3, and 2 minus 3 is minus 1. So we have this as of now, right? Okay, let's try for another value. You will say, okay, Kritika, this is true for this case, but is it true for every case? Let's try to take some value of c. For example, 7. What do we have? We have 2 minus 7, 6 minus 7. What is 2 minus 7? It's minus 5. What is 6 minus 7? It's minus 1. And still the inequality holds. Let's check for c equal to 1. Let's check for c equal to 1. What do we have? We have 2 minus 1, which is 1. And we have 6 minus 1, which is 5. And the inequality still holds. But it is not the exact one that is given in our question. Our inequality stays like that. It does not flip the sign. So this is a false statement. Okay, again, conceptually, very important kind of a question. Now that we kind of understood the behavior of inequalities, let's move towards some little more interesting questions. We need to find the solution set of this inequation. So the inequation is given and this x belongs to natural. This is a very important thing given to us, that x belongs to natural. What does natural number mean? It starts from 1 and 2 and 3 up till n, right? Up till infinity. It goes on. Okay. Let's see what happens. We have 3x minus 2 is less than 19 minus 4x. We have learned about like terms and unlike terms. Let's take the like terms to the side. Okay, so we're going to take the like term here. Now, when we take like term here, what do we have? Instead, I would like to bring a new terminology for you. Let's take the like term like that side. So we have minus, and when we take it on the other side, we get plus. So 3x plus 4x is 7x. Minus 2 is less than 19. Now let's deal with other like term, which is minus 2 and 19. And now take it on this side, right? So we have 7x is less than 19 plus 2, which is 7x is less than, how much will it be? 21. So from here, what do we get? We get x is less than 21 divided by 7. And the final answer we get is x is less than 3. Now let's go back to our question. Remember, your x belongs to n, but x is also less than 3. So x can be what? If x cannot be 3, and if x can be less than that, what values can x take? So x can take 1 and 2. Okay, so this should be your final answer. If you have any questions, you can drop it in the comment section and we'll deal with the questions. Now let's see another question similar to that. But here our replacement set is nothing but the values of x that your equation can take. Okay, so your equation belongs here to whole numbers. Now let's write what whole numbers actually are. So they start from 0, 1, 2 and goes to infinite. Right? Okay, now let's go back to our equation, and then in the end, we always have to come to where x belongs. Okay, so this is our algorithm. First, identify where x belongs, then go back to our equation, solve it, and then go back to where x belongs, and then find how it intersects with our equation. So again, like terms you're going to deal with. So x plus 7 is less than equal to 11. Your 7 goes this side. You have x plus 7, so 11 minus 7, and you have x less than equal to, what is 11 minus 7? It is 4, right? Okay, now your x can be 4 according to this. So if it is whole number, it can be what? 0, 1, 2, 3, 4, 5, and so on. Here, your x can take the following values. Your x can clearly take 4, but it can take all the values less than 4 as well. So 3, 2, 1, and 0. So your x is actually 0, 1, 2, 3, and 4. Okay? Again, if you have any doubts, you're welcome. I will try to comment on all your queries. Again, a similar type of a question, but with fractions, just to understand more conceptuality about the fractions. Again, it is set of whole numbers. Now, I'm not going to write whole numbers again because you guys can refer to the previous question. Again, we have x minus 3 by 2. So I'm going to take like terms. to other side. So I'm going to take x here, and at the same time I'm going to take 3 by 2 here. Okay, so let's take step by step. Let's take x to the other side. It becomes minus on right hand, so it comes as plus. We have the sign as it is. We have 3 by 2 here as it is, and this 3 by 2 is actually negative and it goes here, becomes positive. Okay, so we have 2x is less than, how much is this? It is 6 by 2. What is 6 by 2? It is 3. So you have x is less than 3 by 2. What is 3 by 2? It is 2 ones are 2. Let's divide. What do we have? 3 2 ones are 2. 1 0 is your carry. So 5 sir. Right? 2 5s are 10. So you have 1.5. Now you have one very important thing here, which is x is less than 1.5, and your x can be whole number, right? So what can the x be actually? X can be 0, x can be 1, right? It has to be less than 1.5, therefore you cannot take 2. Okay, let's move towards another question. Again, please check where x belongs and solve the equation. So like terms, I'm going to take, So I'm going to take x this side and I'm going to take 12 this side. Okay. So if 12 is negative here, when it comes on other side, it becomes positive. So I have 3 plus 12 greater than equal to sign, and 2x if goes there, it becomes positive. Okay. So what do I have? 15 is actually greater than equal to 2 chocolates plus 1 chocolate. Always treat your variables like an item that you love very much. I love chocolates. So here we have 2 chocolates plus 1 chocolate, 3 chocolates. Okay, now we need to divide by a positive number. So I'm dividing by 3 on both sides. So I have this. Okay, this leads me to 15. So I have, So I have 3 5s greater than equal to x. Now x belongs to natural, and x can be anything but not less than 5. So x is actually 5 because there is a equality here, but x is also greater than 5. So it is actually infinity from 5 onwards. Okay. Okay. This is a question that was, I think, asked more than once in examination paper. So it is kind of very important question, and I want you guys to pay attention to it. So we have an equation, inequality, and then we need to find the smallest value of x where it is a real number, and smallest value of x where it is an integer. Children and students usually get confused with real numbers and integers. Okay, I need you to take a pause and understand what it is actually. Real numbers is a bigger set. It consists of integers. So this is integers, and this entire big bubble is a real number. Okay. Now let's try to understand it via question so that you can be familiar with it as well. So step 1 always is to solve your equation. Okay. Let's solve your equation. Let's take 16 here and let's take this on the side. So 25 minus 16 is actually less than equal to plus 4x. Okay. What do you have from here? What is 25 minus 16? 9 is less than equal to 4x. And then what do you have? 4 goes for division is less than equal to x. So your x is actually, let's just divide it. 2 point, I think it is going to be 25. Okay, so you have something like this. X is greater than equal to 2.25. Okay. Now you need to find the smallest value of x such that it is a real number. Real number. Real number consists of decimal? Yes. So this has inequality here. So the smallest value is going to be this itself for the first one. For the second one, when it is integer, now x can be note that greater than 2.25. So we cannot consider 2 here, but we can consider 3. And 3 is the nearest integer. Okay, so usually students confuse it because it is 2.25 and the nearest integer to 2.25 is actually 2. So students end up writing 2 here, which is not the case because you need to take inequality very much into consideration and then see the nearest integer. Okay, very good. So far, so good. Let's move towards another set of a question. I think I would like to give this question as do it by yourself, but I'm going to give you a hint of it. So you have two inequalities here. There's no need to worry about the inequalities, but just do the fractions as it is. So first, maybe you can solve for these two, and then you can solve for these two. Okay? I am, regardless of that, going to show you how to deal with questions like this in our next series. But today it was entirely about replacement sets, understanding what whole number, real numbers, integers are, and then understanding the algorithm behind solving the questions related to inequalities. These are dual inequalities. I want you to try it by yourself, and if you are not able to, let's go and meet me in the next session, and I'm surely going to do a lot of questions that will be focusing on finding the solution sets, and just I'll give you a little preview of more other kind of questions that I'm going to do in a short reel further. So, by that note, I would like to end this session, and let's keep on watching the series so that we try to solve major multiple questions and just do well in our exams. Get prepared for ourselves. Okay, all the best, students, and see you in another session with how to solve such questions of dual inequality, how to find solution set, and many more tricky questions. Bye.